Now we are going to discuss about the Jarque-Bera testing. Jarque-Bera test is basically used for normality testing. Now in the CLRM model or in econometrics, we assume that in CLRM basically we assume that um, UI, which is the error term, is normally distributed. Okay, that is our very basic assumption of the CLRM model, that the error term, that is UI, referred as UI, is normally distributed. And there is a reason behind it. Why do we assume that the error term is normally distributed? Why don't we assume that the error term is following T distribution or chi-square distribution or Bernoulli distribution or Poisson distribution? There is a reason behind it that you assume that UI is normally distributed, and the reason is that every distribution, Bernoulli, Poisson, T, chi-square, can be converted into normal distribution. That's why we assume that the error term in the CLRM or classical linear regression model is normally distributed. So basically, if we have to check if the data is normally distributed or not, if any particular data set that is given to us, and if we have to check that the data is normally distributed or not, for that we have to check, and because before checking whether our data is normally distributed or not, we can't apply CLRM or OLS in that data, right? So if I have to apply OLS or CLRM to a particular data, then that data must satisfy the condition of normality. So before applying OLS to any particular data, I have to apply, or I have to check whether the data is following normal distribution or not, right? So for checking whether a data is normally distributed or not, I have to apply the Jarque-Bera testing. Okay, now this Jarque-Bera testing is very important for this particular purpose that it fulfills. So Jarque-Bera testing, which is basically a test for normality. Now I may just want to go a little deeper, but I am just going to elaborate the steps here. So the first step that I am going to state, which is the step 1. So in the step 1, I will just say that we have to set up the null hypothesis and the alternative hypothesis, and the null hypothesis will be nothing but that the data is normally distributed. So null hypothesis is taking that the data is normally distributed. So whenever the null hypothesis is accepted, that means the data is normally distributed. Similarly, the alternative hypothesis is telling that the data is not normally distributed. The data is not normally distributed. Now what is the test static? So step 2, in the step 2 we have to calculate the value of test statistic, and for the value of test statistic we require test statistic is basically calculated, and there are some variables that we require for test statistic calculation, and the test statistic is n divided by 6, and within bracket s square plus k minus s whole square by 4. I may not be going to the derivation of this test statistic, but this is the Jarque-Bera test statistic, and here this n is denoting the samples. This n is denoting the sample size. This s is denoting the sample skewness, and this k is denoting the sample kurtosis. All of this will be given in the question or in the data set. Now if a sample size is greater than 2000, then Jarque-Bera test is very much effective. Okay, so if a sample size is greater than 2000, then the Jarque-Bera is very much effective, and in the step 3 we are going to tell this, that after the calculation of the test statistic, we have to calculate, or we have to compare after the calculation of the test statistic, we have to compare it with a chi-square distribution with 2 degrees of freedom. So basically we have to compare it with chi-square distribution with 2 degrees of freedom. Okay, and if the test statistic is greater than that chi-square value at 2 degrees of freedom, then basically we are going to deal with that we will reject A0. If the test statistic is greater than the chi-square distribution at 2 degrees of freedom, then we will reject A0. Otherwise, if the test statistic is less than the chi-square distribution value of the chi-square at 2 degrees of freedom, then we will accept the A0. So this is all about the Jarque testing, and Jarque testing is very much effective if the sample size is larger and it is greater than 2000. But if the sample size is not large enough, if the sample size is less than 2000, then the critical values are determined via simulation. Okay, so if the sample size is not, if the sample size is less than 2000, then the critical values, that is the value of test statistic, is determined via simulation. Okay.